Ruleby is a Ruby-based rule engine. It's an implementation of a particular algorithm that I find very interesting. And I've got an application I'm working on right now that every day the client has some new and screwed up business rule. And I'm getting really twisted in the code, and I'm trying to find a way to clean that out, make it more manageable, make it extendable. And Ruleby seems like a decent contender, so I thought I'd share with you guys what I've learned about it so far and try to spread the wealth there. So, what's a rule engine? Yeah, it's simply a system for executing if-then statements. And in Ruleby, these are called production rules. So you can create this fairly complex series of if-thens and chain through them to come up to some solution. So if member type is Premier and on-site for 10 months and has invited 20 people and does not have a discount code, and you could just chain those things together using the rule construct in this. And it's much cleaner code than using this whole if-then thing. So what's wrong with if-then? Well, complex code, interdependency, state transitions, basically end up with spaghetti code, and you look like this kid. And you don't want to look like that kid. So, as an example, so you have this kind of quasi-Ruby here, first name and last name, if type, if group name, else if, and you end up in this whole nested if situation. And there are some guys out there who say if you get more than 2 levels deep on nested if-then statements, you're doing something wrong and your code smells. And this is one solution to that problem. Just ask yourself the question when you start seeing code like this. We've all written code like this. What if you want to add a new type? So now there's group and there's individual, maybe there's a meta group or something. And so now you're just adding more indentations and more logic. And if you ask some guys like Alex or Cockburn, they'll tell you this is the single most evil construct ever foisted on programmers, because this is where most of your errors end up being. Because you can get so complicated you can't actually follow the path of execution, short of running it and seeing where you end up. So Ruleby is hopefully a better way of handling this kind of stuff. It's rule-based programming. So basically, you have a rule engine that derives answers from a knowledge base. The knowledge base contains the rules, and then you give it facts to compare against the rules. So let's say you have a blog application and you have authors, and you have all these conditions that if an author this, and an author that, and an author the other, you can put and make those rules up with the DSL that Ruleby provides, and then give it an author and execute the engine, and it will match that author object against various rules that you've created. And once you get all the way through, if it matches a complete chain of rules, effectively tracing all the way through your if-then else's, then it does whatever the action is you tell it to do if all those rules are true. So the 3 parts of a rule engine are the facts, the data or object. So like in this case, your author object or your user object or your account object in Ruby. They use a fancy term, working memory. When you look at the Ruleby documentation, it uses that term a lot. If you look at the actual more academic description of the underlying algorithm, they use the term working memory element, or WME. It's just a fact. It's a piece of information. Then you have the rules that are the if-then statements that you're executing these facts against. Then you have an inference engine, and this is what the meat of Ruleby is, and what the meat of the algorithm is actually how do you efficiently match these facts against the rules so that you can come up with an answer and maybe execute some code because all these things are true. So the Ruleby inference engine is an implementation of the Rete algorithm. For those of you who are pedantic, it's either Rete or Rete, depending on how you like to pronounce it. The guy from Venice, how would you say that? Italian? Rete, there you go. So neither of these pronunciations are correct by his measure, but this is what the book does. So proposed by Charles Forgy in 1974 at Carnegie Mellon. He used it as his PhD thesis in 79 and then wrote a paper about it in 84. And it's from this paper that the public domain algorithm has been pulled out and people have done stuff with it. Years later, he came up with a new one, Rete 2, that he has not released, and he actually has a couple of commercial products based on that, and I'm assuming it's made him a few bucks, but he hasn't released that into the public domain. And most of this information is straight off of Wikipedia and off of the Ruleby guy's GitHub site, which I have references at the end. So, as I call it, the Dirt Farmer's Guide to Rete, the real bare nuts and bolts about it. It builds a network out of the nodes, a network of nodes from the rules. And if you imagine a rule that says if-then, 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 each of those if-thens would be really the if part would be a condition that's going to execute. And when you chain those things together, they call it a forward chaining algorithm for reasons I won't go into because I don't really understand them. But each node represents a condition, and you can chain those together. And when you go from the root down to a leaf through this complete chain, you basically end up where you can execute an action. One of the things that's interesting about this is that when you put a fact in or an object into this thing, you can actually modify the attributes of that thing while the engine is executing. So let's say you have an object, a user object, whose status is locked, and you have a rule that says if this, if this, if this, and then you can change that thing's status as a result of matching these rule conditions. That newly changed user object, maybe it goes from locked to unlocked. Now any rules that exist that look at that unlocked state will also be executed without doing anything. That's just part of how this algorithm works and why it's actually very fast. And I'll show you an example of that in the two examples that I brought along. Finally, at the bottom there is when a factor combination of facts match all of the patterns for a rule, then you can execute an action. And so what about that? Well, it's fast. In honor of my buddy Neil, it's fast. So that's why this algorithm actually gained popularity, because it's actually orders of magnitude faster than other ways of doing this. And I guess that's all in how the nodes are connected and how the memory is stored on the nodes. So using this thing, it took me a while to get my brain around this. The syntax is a little obscure, but when you see it and you kind of boil it down, it's really not that hard to get a hold of. So first rule is you got to build rules in what they call a rule book using the Ruleby DSL. You give it rule conditions, which are really the if part of your if-then, actions to accomplish, and then finally modifications to facts. So that's an optional thing. You don't have to modify facts. But when you have some, for example, a user object, as I described, you can actually change some status on that thing, some attribute, like I said, from locked to unlocked, and it'll be repropagated through that node of rules to see if it needs to do anything else based on this new state. Step 2, create an engine and initialize the rules. That can be done in about one line of code. Step 3, assert facts. Assert is a term they use for basically putting a fact into the working memory. So you take a user object and you assert it into this node tree, into the algorithm, and then it becomes one of the facts and get evaluated against your rules. Again, they use the term working memory just to be fancy. Finally, step 4, fire the engine to match the facts to the rules and have any actions that you've defined then fire off. So building the rules. The rules are defined by the Ruleby DSL, and the author describes that one of the reasons he did this in Ruby is because Ruby is a pretty popular language for doing DSLs. If anybody's ever created a DSL or worked in one, it's very true. Ruby is a great language for that. The particular syntax that he's using right now is called Ferrari, and it's fairly simple. You can create multiple rules inside of a single rule book method, and I'll show you that. And if you compare the way the code looks and how you can organize it using this, it's so much better than that nested if-then, 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 else, 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 if stuff. It allows you to organize your code, it allows you to group the rules together, allows you to very easily see without having to trace through if this, okay, I got a guy who has this status and this color and this size and this number. You don't have to do that. You see the rules straight in front of you. It can be on one line of code. It really makes it easy to figure out. Each rule is still executed independently, though, even if they're grouped into individual methods inside of the rulebook. Finally, you can build rules dynamically. This is Ruby, and I'll show you an example that he provided that's pretty cool, where you can actually dynamically define rules as the rule engine executes, which is a very powerful construct if you need something like that. So the typical rule syntax. So the word rule with a do end block, the identifier, which is optional. So you may have a rule called new customer discount, for example, which I'll show you the example I have. And then you have an array of patterns. You can have multiple patterns for that. And then the context, and then you can do your actions inside that block. I'll show you examples of this, and it'll make more sense. So it's pretty simple. The pattern is where the meat of this is, and where I think it's taken me the longest to kind of get my brain around this. So the basic pattern syntax is, inside that array is a class type, an object handle, which allows you to reference it in the block later on, which is optional, and then 0 or more conditions. And those conditions could be if user status equals locked, or user status equals premier, or whatever. Those kinds of things are what are considered conditions. Class type is required. That's how the algorithm actually takes the facts of a certain type and actually applies the rule to them. So it knows if you have a user object and you have a rule that operates on account object, clearly it's not going to try to apply one to the other. I'll show you an example in the hello that he includes, and this will become quite obvious. Let's make it this thing to come up. Hello. And no, I don't want to do that. What button did I hit? Okay. So here's the hello that comes with the code when you download the example code. So we'll do a really simple one. So we have a rule book, and then we'll define a rule down here. So we have a rule, and we have the pattern here. So message is the class that's being acted on. And this is his example. I'm going to point out something about this. And then you have the object handle, :m, basically the symbol m. Then m.status equals the symbol goodbye. If that is true, if you have a message whose status is goodbye, then puts the message. And the important thing to note here that took me a while to figure out from this example is this m and this m have nothing to do with each other. This m is, and I changed it up here for clarity, this m is a shortcut in Ruleby for method. And all you're calling basically is the status method on the object that's being put into this rule. So this m and this m have absolutely no bearing on each other. And then put v. I'm not sure. At one point I read somewhere why he used v as the context variable here for the block. I don't remember why that is, and I couldn't find it again. But effectively, then anything you want to reference inside here, you're referencing context to the block with the symbol that you gave it up here. So the inputs just prints out the message. In this case, would be goodbye world for this particular one. And then you can see you can, this example here shows another rule, but this time looking for a status equal to hello. And you do your thing, you put it, and then we actually modify. This is that whole thing about modifying a fact while you're executing your rule. You modify it, and when it gets modified, then this rule will get matched, actually. So you start off with this message being status of hello, and then you can give it a goodbye, and it'll execute on that fact twice because you changed the fact. And I'll just do a quick demo of how that works. Let's see, here we go. So there you go. So you get your hello world and then goodbye world. So let's take just a quick peek at that and see why that is. So you start off with a message that says hello world, and where is that defined? Oh, it's at the bottom, sorry. Down below here is actually a message that is defined. It's magic. It's Ruby magic. Sorry, this screen size is tiny. Hey, there we go. So you create a message with a symbol hello for the status and hello world for the message, and you assert that. You put it on the thing, and then you call the match method on the engine, and that gives you the hello world that we saw. But then you modify that fact and change its message and its status, and once it's modified, it gets propagated again through the rule engine, and then this rule now matches, so now you put the message, and this time the message is goodbye world. Anybody any questions on how that works? Yeah?
Well, this seems quite similar to partial generators along the lines of Bison or something like that. And I'm curious in the documentation of the market, how to describe this relationship to those kinds of tools.
I didn't see anything in there about its relation to parser generators or anything else. No mention of Bison, and I've seen Bison described, but I don't know the innards of it, if it's similar to this. Anybody who's got Bison?
It has rules that have to match and actions, and that's the way that most parser generators work. This looks kind of familiar based on tools like Bison.
Yeah, a lot of those use the BNF notation, and I don't believe this uses that under the hood at all. This uses the Rete algorithm as far as putting the conditions on the nodes, and it has a way that it marches up and down through the tree to figure out what actually matches and what doesn't. So I'm assuming it's different. Just a guess on my part. Good question, though. Okay, so that's kind of a basic introduction to what the status looks like. Like I mentioned, the things you need to do to use this, you typically create your rule book class separately, and I'll mention that later on. And then you create an instance of the engine, and then tell it this rules method basically just calls this guy, which executes that, puts that rule into the tree, and then you can assert this message, add it to the working memory, and then fire the engine by calling e.match.
So the modify pretty much tells it to go back into the little station and stuff, correct?
Effectively, yeah. When you modify a fact that has been asserted to working memory, the concept is something's changed with that. We have to reevaluate that object relative to the rules.
Okay, are there others, like calls, like modify?
No, it's assert and modify are the only two. Assert puts it on, modify changes it. There is one other one, which is, I think, retract, where you can take something out of working memory. That is the third one. And actually, I'll show you an example of that in a second. Because you may, if you modify something and execute a rule, you may not want it to continue to propagate, because you could get yourself actually in an infinite loop into a race condition. And you can retract facts off of working memory to take them out once you've processed them appropriately. All right. So there we go on that guy. So notes on conditions. You call the methods on fact objects. So that m dot that I mentioned that was to be confused with the symbol m, really it's just method.x, and where x is the name. Calling all James Bonds, calling all James Bonds. It's just executing the method name with where x is. Most of the examples he gives for conditions simply use equality. There are others, greater than equal to, less than equal to, not. You can actually pass a block parameter that evaluates to true or false. And the syntax for that's a little funky. They use ampersand condition and then curly braces. Or again, just like a method is shortened to m, condition can be shortened down to c. And you'll see that in the next example I'm going to show. So it's c for short. And then condition really is just an alias for lambda, according to the author. And then I'll show you the cart rulebook. There is a store tutorial out there as well that's a little more full-featured example of how to use Ruleby. Close this guy out. So here we go. So in this case, we have the cart rulebook as its own class. And we define a couple of different rules. The customer discounts, you can see it includes two separate rules with the object handle, and then, with the identifier, and then the condition. Your object is a user object. You use the symbol u, which isn't actually used anywhere down in the block, so you really wouldn't need that actually. Then you call the order count method on the user, and this is that shortcut symbology. So he's actually going to use a block here. So ampersand c for the condition. If the count c is equal to 0, if the count is nil, then this rule is satisfied. If that's the case, then assert discount new. So then you create a new discount of 10% and put that on the working memory. And this is an interesting case because you're not actually doing anything. You're not actually doing any action here. You're actually putting more facts into the working memory, as opposed to, if that's the case, then subtract 10%. You're not actually doing that here. You're creating, in this case, a discount object, which simply has a percentage, a product, and a percentage that is discounted, and putting those in working memory, and then they're used later. And then they have a loyal customer discount. If the order count is greater than 5, then give that guy and create another discount of 5%. And then they have another rule that applies to discounts, and you can look at if they're cumulative or not, and then you can either accumulate the discounts or just give them a straight discount. Now, once you've done this, notice that they do a retract, as you asked about. They retract that discount because that discount's been processed by the rules. We don't need it around anymore in the way this is set up. So you pull it off the working memory. Let me scroll this down just a little bit. Then I mentioned earlier that you could dynamically create rules. And this is an example of that. So you have product discounts, and you can pass in an array of discounted product names. And for each of those, it creates a rule from the product name, rule name to sim, and then asserts the discount for each of those new products with that rule. So that's kind of a cool way of creating rules dynamically. So you don't have to write a new discount rule for every product that you add. You can just simply label them as new products, and it'll give you a discount on them. And then at the bottom there is just a little discount class. It's got an amount, and it's whether it's cumulative or not. So that is another slightly more involved example of how to set up the rule syntax. Okay. So Ruleby in a real Rails app, the cart thing, the store thing is a little, it's minimal. It's kind of like your basic blog application or shopping cart application, but it gives you the basic concepts. Nowhere in the description of this does the author really give any kind of best practices as far as whether your rule engine should always be executed in the context of a controller or things like that. Definitely separating out the rules into their own class would allow you, for no other reason as an organizational technique, instead of having this massive nested if-then statement, you could put your rules in different classes. You could have customer rules, product rules, user rules. You can segregate them that way. And then inside of those rule books, you can create the rules kind of the way I showed you here with the different rule methods. When you do this, you can create a rules directory under your app folder. Don't forget, though, to add it to the load path so that Rails knows about it. Inherit it from Ruleby rulebook, and then define rules with conditions and actions, or not. As we saw just a second ago, you don't need to have actions. You can have rules that actually create more facts and stick them in the memory. And then you can assert and or modify facts, and those facts, again, are just your Ruby objects that you want to run the rules against. So firing the engine, like I said, typically done in a controller. As that example, I didn't show you the controller yet, but I will next. Basically just create an engine, get a rule book, and initialize the rules, assert facts, and then call engine.match to fire it. And that's when it'll take the facts that it has on hand and execute all the rules within the context of those facts that you've given it. And let me show you real quick what the controller looks like. Oops.
So is the output then just like it's going to modify the object you give it? What is the output of the
Well, it does the actions that you tell it to do, and I'll show you what I mean by that here with the actions are whatever you want them to be. They could be launching a delayed job, be firing off an email, could be changing a value in a database table somewhere, could be whatever you want it to be. It's completely arbitrary. So this is an example in the carts controller in the store tutorial example. Basically, you get a cart, and you want to look at the items in the guy's cart and apply any discount rules to the products in there. So by having above there, it includes the Ruleby, so you have this engine thing available to you. So you create an instance of the engine. You pass in the engine to the rulebook, so the rulebook and the engine are now connected to each other. And then from that rulebook, you call the customer discounts method, which asserts more facts into working memory. It doesn't actually do any action. And then you have the product discounts for products X, Y, and Z. So if you had a product actually named X, Y, and Z, you would now have dynamically created 3 rules to give a discount on those 3 products. And then you take your current user. This uses auth logic in the background. So you add the current user in as a fact, and you add the product that you have in the cart as a fact, and then you run match. So that's going to fire off the engine. In this particular case, what it's going to do is it's going to end up changing the price of the product in the cart. So it's going to give you a discount, basically, on the price. Let me flip over to the rule again. So let's see here. Just flip back. The last time I did this, I had to search through. And okay, so the discount, yeah, right here. So this is a case where the action actually does something to the object, the product that you pass in. So the discount, which is a field, an attribute of the product, gets, in this case, for a cumulative discount, maybe it's 10% for being a good customer and 15% for new products. So you get a 25% discount on that product. Or in a case of a non-cumulative discount, it just subtracts the number. So this symbol here is the object, the product object you passed in, and it's actually modifying the discount attribute of that product. So when this product comes out of the rules engine, here, you cart, add product, that product has been discounted appropriately through the rules engine. Logic's a little hard to follow until you get your brain around it. It's taken me about 10 times to go through it, to be able to stumble through it as well as I am currently stumbling through it. And that's kind of the meat of it. You can create fairly complicated logic, which would otherwise be these crazy, hairy if-then-else statements. maybe bringing other objects into play, and you can kind of constrain them and combine the rules. And in my case, for one of my clients, the client in San Antonio, where I get a call from them about every other day that they wanted to change something, this would be a really great construct to be able to respond to their changes more easily. Yeah?
Okay, so I follow what happens in terms of you've got rules that match and they fire off individual actions. But how do you know in what order those rules execute? For instance, say that you have this, you create this engine, and then you call match. And at some point, some of the discounts apply just pure subtraction from the discounts, and some of them apply a multiplicative discount. And the order in which those fire would actually change how much the discount was. So what I can see that you have a before state, then you have a match state, then you have an end state. And during that match state, some of those rules have matched. But I can't really envision how the flow of execution works there in the way that I could for an if-else change.
Sure.
I can answer that.
Go ahead.
Well, basically, your rules better say what happens in all cases. They need to be sufficient to get the resolve all of the ambiguity exists.
So they go all multiplicative. Don't do anything.
No, well, Scott, what you say is actually true. You obviously have to understand what your business logic is and create the rules and run them correctly. But your question is really a good one, and I left that out of the presentation in the interest of time. There is a thing called conflict resolution in this, that there are 3 different ways that it does conflict resolution in order last in, first out. So the last rule that's asserted will trump another rule. There's a priority scheme, and there's a saliency scheme, which I won't go into. But there are ways to massage how it solves that problem if you have 2 rules that could both be satisfied at the same time on the same fact. Which one takes precedence?
How do you know it's the last, though? Just the order was defined, or?
I don't recall, actually. He calls it LIFO, last in, first out, but I'm not sure if that's the last rule to touch a fact, or I'm not exactly sure what he means by that. And since I was glazing over that to give this part, I ignored that part. Yeah?
So you only actually run, for each match, you only run one action, right? You're not going to run, you're not going to match 2 rules, run 2 actions, right?
I don't see any reason why you couldn't. If the rules, for example, if you had, in this particular case here, you are actually doing multiple actions. If you were to match the new customer discount, well, you wouldn't match both of those, but you could have 2 rules, both of which get applied, and you may have an action that sends off an email and maybe one that does something else, and it will fire off each of those actions the way they're listed here. You could. Does that answer your question?
Your hello world has 2 actions.
Yeah, absolutely. I haven't played around with this in the context of the application that I'm kind of eyeing it for, and that'll certainly be the trial by fire. But playing with the demo and with the hello world, it starts to make sense after playing with it a bit about how this stuff works, at least on the simpler cases. Yeah, Garen?
It's worth pointing out that the way the time way the class is properly as it's doing.
That is true.
So you're going to have certain types of sets of rules. You can better off with this type of rule engine that will act as from the conclusion to the support or work in some application. Depending on your rule set, flows in the memory.
And that is the common criticism of this particular algorithm, is that it is memory consumptive. And they do describe, if you look at the description of the Rete algorithm in Wikipedia, they have links there that go, this is a forward chaining inference engine algorithm. They have backward chaining that sort of solve that problem. They have their own quirks, and there's always pluses and minuses on these things. And I'm not sure at what level you run into that problem. They have a mismanners benchmark that the author describes on his GitHub site. And this thing performs well on that benchmark up to a certain point, and then it starts to fall off a cliff. And I don't know how involved the level of the benchmark is where this thing starts to fall down, but he does describe that aspect of it. So.
If you're interested in playing with inference as well, I did a presentation a while back about Python.
Oh, that's right.
It has both forward and backward inference.
Sure. Scott, did you have another question?
Adding a new rule requires a Ruby program.
Yeah, this is not something, and I thought about that as if this is where you're headed, that you could have these analysts or these domain experts who could write rules for you in a DSL.
I mean, I had contacted me, I had a client with exactly this problem. They had to do basically a new rule for applying a discount in a different situation, and everything else, of course, the existing rules were hard-coded. So
Sure.
They wanted to know, why is this going to cost so much? Well, and I just wondered whether something like this would have a user-friendly space to put on it so that they could make their own rules. Or is that just happening to trouble?
Well, you always introduce a point of failure when you let the user or someone who's not the programmer basically write code for you, whether it's in a DSL or a template or something like that. So, I mean, but if that's what the client wants, then you can do it by all means. Yeah, Matt.
What's your experience with debugging and testing rules?
I have zero other than working through all the tutorial exercises here. I haven't tried to debug it at all. I mean, but it's not launching any processes or anything like that. So I suspect you could, you get his implementation of the algorithm when you pull the gem down. So you could probably debug into that. Is there?
That might be hard to know why the rule doesn't apply or why something doesn't work. You don't get the output of
Sure.
What happens.
Right. And I thought about, as part of this demonstration tonight, I thought about adding extra rules and putting in like write statements or put statements to show where it was stepping through. And I didn't do that in the interest of time, but that would be a great exercise to try to do that, especially if you're messing around with the priority and all that. Yeah, Gary. No. Yeah.
To a limited extent, if you get in a simple interface, or if there's somebody who's capable of doing a database design, then that's probably the right kind of mindset to also be able to do this. But a lot of these very smart people can't do this.
So you're saying maybe the client won't be able to do it?
Yeah.
The client won't be able to do anything complicated.
Well, and the counterpoint to that, I think, is that when you have a setup like this, where it's not a hairy 52-line if-then-else statement or 152-line statement, if they said, we want to add a new recent customer discount, then, I mean, it's literally as hard as adding a couple lines here. And if you're talking a Rails app, you just redeploy it to the server. And it shouldn't be that 100 man-hour estimate and $30,000 bill that everybody fears when they ask for what they think is a small change. So this is a case where the programmer can actually help out the customer and make the system more flexible, even if you are the guy who has to cut the code directly. Because now with a Rails app, I mean, how hard is it to git push, cap, and deploy? I mean, that's really easy. Yeah.
I'd also say that one way you might think about using something like this is not using it in production, but maybe using this to generate the code that you're running. That if you wanted something that would run fast and not have to forever be dealing with these closing questions, you'd have this sort of be generating the methods that calculate the discounts or whatever. And not have to keep doing this. Think of it as a macro.
And I don't want to use up all the time here, so I'll put these two up. If you just Google Ruleby, almost guaranteed the first one that comes up is this guy. Andy is his name on Code Aspects on GitHub. And then if you're interested at all in the history of it, he links to the Wikipedia entry about Charles Forgy's implementation or creation of this algorithm. So in the interest of time, I will step off the stage. If you have more questions that I can possibly answer, I will be at rock bottom afterwards. Who's up next? Okay.